Okay, so now what I want to do is sort of summarize all of the end behaviors, including polynomial functions and rational functions. Many students get confused because they feel like there's so many end behaviors, but really when you summarize it, it's not bad at all. So let's get down to it. The first thing I want to mention is, let's say when you look at your leading term, okay, let's look at the leading term. If your leading term is x to a power, okay? If your leading term is x to a power, then what that means is both ends grow, okay? Now let me put that in quotes. What I mean by that is both ends approach positive or negative infinity, and we'll be very clear about what I mean by that shortly, but I'm trying to get the general idea to you here so that you can see the big picture, okay? Let's make this font a little bigger. There we go. Okay, all right. Similarly, if your leading term is the reciprocal of x to a power, so it's 1 over x to a power. If you're dividing by x to a power, that's a great way to say it. So if you're taking notes, you might make a note. If you divide by x to a power, then both ends approach 0, okay? Because when you're dividing by something really big, remember end behaviors whenever x is a massive number, you're going to approach 0. Now, I'm not saying if you're approaching 0 from the negative or the positive side, so it could be from either. Okay, so that's important to understand, okay? All right, so if you're left with x to a power, both ends grow. That means go to plus or minus infinity, okay? Just to be clear, it can go to positive or negative infinity. That's what we'll call as growing. And if you're dividing by x to a power, both ends approach 0. All right, there's one other case. If the leading term is a constant, let's do it this way. If the leading term is a constant, then the ends are horizontal at that constant, okay? So if it's 5, you've got a horizontal line at 5 on both ends, etc. So the way that happens is when you simplify your leading term, all of the x's cancel. So if you've got x's left, you either have x to a power or you're dividing by x to a power. If there are no x's left, you have a constant, okay? Now, so again, these are general ideas. Now, if you have, let's talk about even powers, okay? If you have x to an even power or 1 over x to an even power, then what that means is, let's move my colon here, then both ends are positive, okay? So that means they're both above the x-axis. If you raise a positive number to an even power, you get a positive number. If you raise a negative number to an even power, you get a positive number. Both of these are positive numbers, okay? If you have odd powers, okay, such as x to an odd or the reciprocal, 1 over x to an odd, then the left end is negative, because on the left end of a graph, you're looking at negative x values. If you take a negative x value and raise it to an odd power, you get a negative number. Same thing as if you divide by that. If you look at the right end, you've got a positive x value, therefore the right end is positive, okay? Now let's put all this together now. Let's kind of apply these general concepts to think about all the different end behaviors you could encounter. So let's look at them now. So let's say we have x to an even power. Well, we know that we're not dividing, so we know both ends grow. Okay, so we know both ends grow. And because it's to an even power, both are positive. Both ends are positive. So if we look at that, both ends grow in the positive direction. Easy, okay? Now, if you have so that's if you have a positive coefficient, okay? So that's if you have a positive coefficient. If you have a negative coefficient in front of x to an even power for your leading term, you just flip it over. So it's going to look like this. Now, what I'm going to do, I wanted to mention that now, but I'm going to go back and erase that because we know how to flip graphs over the x-axis, so I'm not going to concern ourselves with that just yet. We'll come back and do that at the very end with all of them. Okay, so let's look at the reciprocal of that. What if I have a positive coefficient times 1 over x to an even power as my leading term? Well, here I'm dividing by x, so my ends are going to, they're going to shrink. They're going to approach 0, okay? They're not going to equal 0, but they're going to approach 0. And since it's an even power, I know both are positive. Let's say both are positive. So if I look at that, if I look at a picture of that, well, I've got to be above the x-axis on both ends, but I need to be shrinking. So as I move to my left end, I need to be shrinking from the positive side, and on the right end, shrink from the positive side as well. Okay? Easy, right? Let's look at the odd powers. If I have a positive coefficient times x to an odd, well, because I'm not dividing, both of my ends will grow. But since it's an odd power, the left end is negative and the right end is positive. But they're both going to grow. So let's see what that looks like. So I need to grow in the negative direction on the left end. So that means I'm going to do this. And I need to grow in the positive direction on the right end. That's going to do this. Now, just to be clear, if this is x to the first power, these are actually going to be straight lines and not curves. Okay? But this is just a general summary. So if it's x cubed or higher, if you have a higher power than 1, these are curves. But if it's x to the first power, these are actually straight lines. Okay? All right, so that's a positive coefficient times x to an odd. Let's look at a positive coefficient times 1 over x to an odd. We're dividing by x to an odd now. Since we're dividing here, both ends shrink. But since it's an odd power, the left is negative, the left end is negative, and the right end is positive. Okay, so let's see how that plays out. Again, what I mean by shrink is approaches 0. So on the left end, I need to approach 0, but from the negative side. So I need to be below the x-axis. And as I look at my left end, I need to get closer and closer to 0. On my right end, I'm positive, but I need to shrink. So I'm going to start positive and shrink towards 0 on the right side. And there we go. Those are x to powers and reciprocals of x to powers. Okay? Now, that's it. The only other thing is, if I go back and change my coefficient to a negative, so if I make this a negative coefficient, it flips over. So they're both going to grow in the negative direction. If I make this coefficient negative, it's going to flip over the x-axis. They're both going to approach 0 from the negative side instead of from the positive side. If I make this coefficient negative, I'm going to grow in the positive direction on the left, grow in the negative direction on the right. I'm just flipping over the x-axis. And if I make this a negative coefficient, I'm going to shrink from the positive side on the left, shrink from the negative side on the right. Okay? So those are the 4 hardest end behaviors involving x to a power. The last end behavior is if you simplify your leading term and all of your x's cancel and you just get a constant, if it simplifies to some constant c, well, you need to locate that constant c on the y-axis. Let's say it's right here. It could be above or below the x-axis. We don't know. If it's a negative number, it'll be below. If it's a positive, it'll be above. But you simply approach that constant on both ends. Let's use a different color here. So your ends are horizontal at that constant. And that one's the easiest, I believe, because there's no x's left. You just get a constant end behavior. And that is a summary of all the possible end behaviors, understanding the big picture, hopefully. I hope it was helpful for you. Good luck, get some practice.